Hello everyone, myself Vasna Sharma. My today's presentation topic is flip-flop conversion. That means how can we convert from one type of flip-flop to another flip-flop. So here I'm using the SR flip-flop that we have to convert in JK flip-flop. That means we are converting SR flip-flop to JK flip-flop. So we have some steps for converting one type of flip-flop to another flip-flop. First, write the characteristic table of required flip-flop. Second step is write the excitation table excitation table of given flip-flop. Third, using excitation table, we have to design a conversion table. Then simplify the logic operation using K-map. And finally, draw circuit using expression. So these are some steps that we will use from one flip-flop to another flip-flop. So here we are converting SR flip-flop to JK flip-flop. So first we have to draw the characteristic table of SR flip-flop. Characteristic table of JK flip-flop. For that, for characteristic table, we have present state Qt, inputs are J and K, and output is Qt plus 1. So we have three inputs, that means the total combination of these three inputs are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 101, 110, and 111. Outputs Qt plus 1 for these inputs are 0, 0, 1, 1, 1, 0, 1, and this is 0. So this is the characteristic table of JK flip-flop. Now we have to draw the excitation table of SR flip-flop. So excitation table of given flip-flop, that means SR flip-flop. In excitation table, we have a Qt and Qt plus 1 at the input side and inputs S and R at the output side. For two inputs Qt and Qt plus 1, we have four combinations 0, 0, 0, 1, 1, 0 and 1, 1. Excitation table for this is 0, don't care, 1, 0, 0, 1, don't care, 0. This is the excitation table of SR. Now we have to draw the conversion table for this. For conversion table, we have to write the Qt JK, that means characteristic table of JK flip-flop, Qt JK, Qt plus 1, and output side we have the input conditions S and R. That means we have to take a characteristic table at the input side, Qt JK Qt plus 1, and the input S and R to output side. So we have to draw all the combinations of characteristic table 0, 0, 0, 0, 1, 0, 0, 1, 0, 1, 1, combinations 0, 0, 1, 1, 1, and now we have to find the SR inputs. So for S and R, we have to check the excitation table of SR flip-flop. So QT and QT plus 1, we will check the QT and QT plus 1. Here QT is 0 and QT plus 1 0. So according to the excitation table of SR flip-flop, if QT and QT plus 1 are 0 0, the inputs S of S and R will be 0 don't care. For 0 and 0, it will again 0 don't care. For the QT0 and QT plus 1 1. For 0 1, the SR excitation table, the output of SR is 1 0. 1 0. Same we will use here, don't care 0. 0 1, don't care 0 0 and 1. So we have find all the combinations of S and R according to the QT and QT plus 1. Now next step is simplifying the equation, simplify the S and R equation with the help of K-map. So for the K-map of S, for S, we have to draw the K-map table. We have three inputs QT, S, QT, J and K. That means we are making K-map of 8 cells. Here QT and this side will be J and K. 0, 1, 0, 0, 0, 1, and 1 and 1, 0. The values for S are 1, 1 here. For 1, 0, 0 it is 2 here and for 1, 1, 0 it is 2 here. So the group will be this 1, 1. So for S, for the K-map of S, the value of S is equals to J Q. Now for F, for R, for the K-map, is Q is 0, 0, 1. So these value, this is don't care, and this will be 1. Group is this. So for R, it is R equals to Q and K. Now, next step is to draw the circuit diagram for this JK. So for draw this diagram, we have two equations S and R. We have two inputs S and R. The value of S is J Q bar. Here this is Q and this is Q bar. This is the log bus. So for S, this is J Q bar. So this is the AND gate. One input is J and another input is Q complement. That means Q complement. Right? For R, we have Q into K. One input is K and another input is Q. Right? So this is the flip-flop conversion. Here we are converting SR flip-flop to JK. These are the references. Thank you.